Something is amiss with Mercury, according to the latest insider reports, as the James Webb Space Telescope has uncovered evidence suggesting the planet may have once hosted life forms. But that's not all. Mercury could be completely different from what we previously thought, potentially hiding secrets right before our eyes. Studying Mercury has always been considered exceedingly difficult and risky for good reason, but new revelations are now shedding light on this elusive world in the heart of our solar system. Mercury, often overlooked in discussions about major astronomical discoveries, is a rocky planet slightly larger than Pluto and much smaller than Earth or Mars. It was long considered too hot to support life or any form of vegetation. However, recent discoveries of water ice on the planet are slowly reshaping our understanding of this mysterious world. It now appears that we might need to completely reconsider our view of the solar system. Mercury, a world once believed to be a scorching furnace, is showing signs of having more complexity than we ever imagined. Mercury's landscape includes enormous features like the Calorus Basin, which spans over 1,500 kilometers in diameter. These striking formations, some up to 3 kilometers high, are known as lobate scarps, while other features include craters, which have likely formed due to the sublimation of elements such as sulfur and potassium. At its poles, Mercury has permanently shadowed craters, keeping temperatures low enough to preserve water ice. A surprising finding, as scientists once thought the planet was too hot to sustain water in any form. While temperatures on Mercury can reach up to 427 degrees Celsius during the day, they plummet to around -173 degrees Celsius at night. This extreme temperature fluctuation is due to Mercury's lack of atmosphere, which prevents it from retaining or distributing heat, unlike Venus, which has a thick atmosphere that traps heat, causing constant temperatures of 467 degrees Celsius. On Mercury, however, these temperature extremes open the possibility that there may be relatively mild zones, particularly in the shaded areas or beneath cliffs and rocky outcrops, where life could potentially exist in sheltered environments. The study of Mercury goes back as far as 265 BC, when the Greek astronomer Timochates first observed the planet. Despite this early observation, it was difficult to study Mercury due to its proximity to the Sun. It wasn't until the advent of modern telescopes in the 17th century that astronomers were able to make more detailed observations. In 1631, the French astronomer Pierre Gassendi recorded Mercury's transit across the Sun, and in 1771, German astronomer Johann Elert Bode determined the planet's orbit. However, Mercury's rotation puzzled scientists for years. In the 19th century, the French astronomer Urbain Le Verrier noticed irregularities in Mercury's orbit that couldn't be explained by the gravity of the known planets alone. He hypothesized the existence of a previously unknown planet, which he called Vulcan, located between Mercury and the Sun. For many years, astronomers searched for Vulcan, but it was never found. It wasn't until Albert Einstein's theory of general relativity in 1915 that these anomalies were explained, as his theory showed that the Sun's gravity distorted spacetime, which affected Mercury's orbit. In terms of actual exploration, the first detailed images of Mercury were taken in 1974 by NASA's Mariner 10 spacecraft. These close-up images revealed the surface features of Mercury, including craters and cliffs, and provided the first real look at the planet. Mariner 10 also measured Mercury's weak magnetic field, a surprising discovery, since it was previously believed the planet lacked one due to its small size. After Mariner 10, there was a long hiatus in Mercury exploration. NASA was reluctant to send more missions to Mercury because of the difficulty involved in overcoming the Sun's gravitational pull and the harsh conditions the spacecraft would face. It wasn't until 2008 that NASA launched the Messenger mission, which focused on exploring Mercury's surface, atmosphere, and geochemistry. The planetary courier has effectively dispelled rumors that NASA no longer has an interest in exploring Mercury for any other reason. The courier successfully entered Mercury's orbit in 2011, and by 2015, it had provided fresh insights into the planet's geological history. This included exciting new evidence of volcanic activity, images of vast lava plains, and signs of water ice in the polar craters. The data from the courier sparked considerable interest among scientists, as it suggested that Mercury could be far more complex than we previously thought. In particular, Evidence of the planet's turbulent past hints that Mercury was and remains geologically active, which challenges our understanding of its history. Some researchers believe that Mercury was once positioned differently in the solar system and was later pulled inward by Jupiter's gravity. What if Mercury had once been situated in the habitable zone and could have even hosted life? Some of Mercury's landscapes resemble rocky worlds like Earth or Mars, prompting scientists to consider the possibility that Mercury's early history was much calmer than we had assumed. Now, the James Webb Space Telescope, JWST, aims to shed new light on these questions. Thanks to its study of planets like Jupiter and Uranus, we already have new insights into the gas and ice giants. Scientists are eager to determine if we need to rewrite the history of our solar system. When the JWST turns its gaze to Mercury, it will use specialized filters to study the planet as it orbits near the Sun. The telescope is particularly suited for this task, as it was designed to capture exoplanets passing in front of distant stars. Mercury, being such a small dot near the Sun, will allow the JWST to detect subtle variations in light and clearly differentiate the reflected light from the Sun and Mercury. If successful, this observation could provide much more precise data on the chemical composition of Mercury's surface. Scientists hope the telescope's findings will reveal whether Mercury is truly a dead and cold world, or whether it has been underappreciated and may still possess surprising geological activity. If the JWST uncovers further evidence of water on Mercury, it would be groundbreaking. This discovery would force the scientific community to reconsider Mercury's place in the solar system and recognize it as a far more complex and strange world than we previously imagined. Although Mercury is often overshadowed by its more prominent neighbors, its secrets continue to captivate researchers. Mercury's surface is a patchwork of craters, with some large impact basins, like the Caloris Basin, a massive impact crater more than 1,500 kilometers wide, serving as a reminder of the planet's violent past. This impact, along with volcanic emissions, has reshaped the planet's surface, offering clues to its development and raising questions about its internal processes. Mercury's proximity to the Sun results in an extreme climate, with temperatures fluctuating between 427 degrees Celsius (800 degrees Fahrenheit) during the day and -173 degrees Celsius (280 degrees Fahrenheit) at night. These conditions make it challenging for life to exist, yet recent discoveries of water ice in permanently shadowed craters at the poles have fascinated scientists. The existence of water on Mercury is particularly significant because it was once believed to be too hot to support water in any form. However, areas near the poles appear to trap water molecules in permanently shadowed regions, suggesting the potential for future exploration and resource extraction. Mercury's orbit is uniquely fast, completing a full revolution around the Sun in just 88 Earth days, while its rotation is slow. This creates a distinct pattern of day-night cycles and solar exposure. Studying Mercury has been difficult for space agencies due to the challenges posed by its close proximity to the Sun. The Mariner 10 mission in the 1970s provided the first close-up images of Mercury's surface, revealing its cratered terrain and geological features. Later missions, such as the Messenger spacecraft, enhanced our understanding by mapping the surface and studying the planet's magnetic field and exosphere. Looking ahead, the James Webb Space Telescope promises to revolutionize our understanding of Mercury. With its advanced imaging capabilities, JWST will allow scientists to examine Mercury's surface in extraordinary detail. By observing Mercury as it passes in front of the Sun, JWST will analyze the planet's atmosphere and surface features, offering new insights into its geological history and potential for holding water or other volatile compounds. The findings from JWST could reshape our understanding of Mercury's formation and evolution. By comparing Mercury with other rocky planets in our solar system and beyond, researchers hope to uncover general principles that govern planetary development and habitability. In the end, Mercury remains a fascinating puzzle in our solar system. Despite its harsh environment and small size, the planet continues to surprise us with its geological diversity, orbital characteristics, and potential for harboring water ice. Future missions and advances in space observation technology hold the promise of uncovering even more of Mercury's secrets, offering new perspectives on the evolution of terrestrial planets and the conditions necessary for life. These advances not only enhance our knowledge of Mercury but also contribute to a broader understanding of planetary science. As we uncover more of Mercury's mysteries, we may gain insights that shape our understanding of planetary formation and evolution throughout the entire solar system. Each new discovery adds to the puzzle, helping scientists piece together the history and characteristics of this intriguing planet. As we await the next revelations from JWST and other space missions, Mercury remains a focal point for studying the complexities of our solar system. Its mysteries are far from solved, and every new finding deepens our curiosity about the dynamic and ever-evolving nature of our vast universe.